Okay, so looking at applications, kind of read through the problem here real quick. So ball is thrown off the top of a tower. We have a function that represents the ball's height, s. So a lot of times in like in physics questions, we see this letter s used for height rather than h. So unfortunately, but just going to use that. So s at t seconds after being thrown. So here we have a function representing that. So s is in meters. Wants us to know when the ball reaches its maximum height and what the ball's max height is. So I think it's definitely helpful to kind of sketch this out to kind of see, just see it better than just have to think about it. So try to make it a little bit more concrete than being so abstract. So I would suggest you guys do a little sketch. And so when we look at our function, you should notice that t is in where the x normally is. Right? So that means that t is our x variable. So this is our t-axis. So if t is the x-axis, then the other variable, which is s, must be our y-axis, which also makes sense since it's talking about s being the height. And then the height is in meters, and of course t is time, which is in seconds. So kind of getting some of that context down, like what do these things actually represent, okay? That's how you can tell from a function which one is x, which one's y, even though they changed the letters. The other thing too, right? This would normally be x squared, right? But it's, so letting us know it's t is here. Then there should be, I'd say, 3-ish things you guys should be able to tell me about this graph so that we can sketch it. What are some things we know about this graph so we can sketch it out?
Is it a parabola?
How do you know it's a parabola?
By the square.
By the square, okay. So we're going to draw a parabola. It's good to know. Opens down, how'd you know it opens down, Maddie? Maddie, how do you know it opens down?
The negative in the front.
The negative in the front, okay. So one other thing you guys should be able to tell me about the graph, just by looking at the function. Y-intercept is 15. Right on, Katie. Okay. So our y-intercept is 15. It's a parabola that opens down. So wherever you think 15 is, right? Throw that on your y-axis, your s-axis. It's a parabola that opens down, so it should do something kind of like that. And of course, mathematically there should be arrows on the end of this, but realistically that doesn't make sense. We think about the height there being 0 on the x-axis or the t-axis. So height of 0 would generally be the ground, and generally we talk about throwing balls and stuff like that. The ball would not go below the ground, so realistically we do not need arrows there, but mathematically they would be there. Okay, cool. Good job with that. And then as I read the question, all right, when does the ball reach its maximum height and what is the ball's maximum height? So what's up with this word? What are they referring to there? Okay, I can use some vocab though, Maddie, instead of saying the tallest point. What's our vocabulary there? Yeah, right, Ruth. It's the vertex. So anytime we see the word maximum or minimum for, we're talking about a quadratic, it's talking about the vertex. And the vertex is a point, like you were saying, Maddie, so it's not just a point, it's made up of 2 coordinates. So within that vertex, we have an x value and a y value, okay? And the questions are designed to relate to one or the other, okay? So when does the ball reach its maximum height? This is a when question. When deals with time. That's a time question. Well, what's time to us here? Time is our x-axis. Time is our x coordinate. So that first question deals with how do we find the x coordinate of the vertex? Right? And the second question says, what is the ball's maximum height? Right? Actually, what is the height And so that's a height question. So that's our y coordinate. Yeah. And so you just got to be aware of what they're actually asking you for. Okay? Because if all it said was, hey, what's the ball's maximum height, then you technically wouldn't need to tell or find x, right? Or your answer should only talk about y, right? Or if it said, when does the ball reach maximum height, you don't need to find y. You wouldn't need to talk about it. Okay? So it's making sure you're answering the question that they're asking. Okay? And it does relate to different parts of the vertex. Okay? So that first question is asking for the x value of the vertex. How do we find that? What's x equal to? What's x equal to? What's our formula to find x? Yeah, right, negative b over 2a. Okay, this is something we talked about 2 class periods ago. Okay. It is something you guys need to know. Okay? How to find x. From standard form, how do you find x? Negative b over 2a. So this is really a time question though, so I'm going to say t equals, not x equals. Still the same formula, negative something over 2 times something. What's our b value? What's our b value? Your 35.77, yep. What's our a value? Yep, negative 4.9. Not really. Okay. So there's what we need to put in our calculator to figure out what that's equal to. Okay. Make sure you're typing that in your calculator correctly. Okay, I'm going to flip over real quick. So negative 35.77 divided by 2 times negative 4.9, right? So as I type that in the way I said it, right, we get that answer. So this calculator is kind of interesting because it doesn't, the way it shows the answer there, or the way it shows the work up there in the top left about what it actually did. A lot of calculators don't do that. So here's just saying what it did, and that's not what we wanted it to do. And then we go and look at the answer, and we kind of say, well, that answer doesn't make any sense anyways, because this is a time question. That'd be 87 seconds, which is over a minute. Thinking about throwing a ball up in the air and have it just to get to the maximum height, over a minute, doesn't make sense. Right? It's way too much time. So you could see pretty obviously that we typed something wrong there. Okay. So remember the idea is with this, and I'm pretty sure we talked about this today, you need parentheses here. Okay. You want to make sure the calculator does that multiplication first and then does the division. So how to type that correctly. So 35.77 divided by 2 times negative 4.9. And there I got negative 3.65, which of course doesn't make sense. We can have negative numbers, and that goes back to because I forgot to type in the negative on the numerator there. But I should recognize that mistake and then know how to fix it. That, I just need positive 3.65. I could also be questioning myself, why did I even bother typing in the negatives? Because a negative divided by a negative is always going to be a positive. Seems kind of silly to type them in, it's just wasting time. Yeah? But positive 3.65 makes more sense, right? In context of the question, it's the amount of time it takes for the ball to reach its max height, 3 seconds, seems more reasonable. So 3.65 seconds is pretty exact, right? We really don't have any concept of what 500ths of a second is. Just thinking about it, it's so short of a time, we really don't have a concept of that. But one thing I don't want to do is I don't want to round this number right now because I need it for something else, right? And so you never want to round during the middle of a problem. So I'm going to leave that there right now. Or if I wanted to go ahead and interpret that, I could say, about 3.7 seconds to reach max height. If you ask me to kind of guess what 3 seconds would be like, just I could do pretty well. 3.5 seconds gets pretty tough. Down to decimals of seconds is pretty tough for us to do. So you might be okay, just saying about 4 seconds, but generally I would try to keep about a tenth. So I think what I've noticed when they were doing their problems online, that they made sure their answers were more nice. So it should be pretty obvious like what they're expecting from you, or they would say, as far as like the rounding that they want. So, okay. So there's our time answer, right? And it says, what is the ball's maximum height, which is a y question. So how do we figure out what y is? Nope, distance equation is 0. Yeah, we need to plug in 3.65. Okay, so we found x, so now find y, we plug in our x value. So we're going to take s of 3.65. So again, we do not want to use anything rounded. So that 3.7, that was for us like just to talk. Or if he's rounded it to 4, that's for talking, but you cannot do the math with that number. Got to use your exact number here. And you should be able to write that in the calculator just like that is. And it should be fine. It's really fractions that we got to watch out for with calculators, where a lot of issues can happen. So I'm going to just type that into the calculator. Are any of you guys using a TI calculator?
I am.
Okay. Do you know how to do the second answer function?
Yes.
How about you, Ruth? Okay. So that's what I would do here, especially with, I guess I need to fix mine since I typed it wrong. This app allows me to do something different, which is still the same idea though. So I do the negative 4.9, and then I want that last number that I just used. So for you guys doing the TIs, you would hit negative 4.9. I'd probably put a parenthesis, and then all I have to do is just tap. Okay. So I just tap on that number above on the screen there, and it lets me bring it down. You guys will hit the second answer, bring that down, and then square that. And then plus 35.77. Again, I want my answer back again, so I hit second answer, or for me, I just tap. And then plus 15. So especially if you have a gross decimal that you're using, and you don't want to have to type it all out, because again, the more you type, the more chance that you have just flipping 2 numbers around or missing a number or stuff like that. Okay, so letting the calculator just hold on to that stuff, it's better off. Okay, so then we get 80.28. That's meters. We go all the way to the end of that. That's like 5/100,000ths of a meter. I have no idea how big that is. It's super tiny. And so it's way too accurate for anything that we're doing. The 8 is at the 100th of a meter, which is centimeter, right? So that'd be to the nearest centimeter, which is pretty darn close to anything, right? And then, the 2 is at the 10th of a meter, which would be a decimeter, which would be about that far off. If we went from 2 decimeters to 3 decimeters, so don't have an exact idea like what you should be rounding to here. Again, like if it was a test or something like that, if I was writing a test, I would make sure I would put like what I want you to round to. Again, I think the computer did a pretty good job of like trying to make the problems so they were really neat. I did not have the time in my life to sit there and try to figure that out last night, so I'm just going to round this to the nearest tenth though. So I'm going to say 80.3. If I needed that number for some other calculation, I would again just hold on to that number. But since I'm done with the problem, I can go ahead and start talking about it. And as I interpret it, I'll just go to the nearest tenth of a meter. So. but since I did round it, I am going to use a word that indicates that. Right? So I said about 80.3 or around 80.3 or approximately 80.3. So it is important that you indicate if you are doing that. Again, I'm talking more like if you're writing this out for me by hand, but the computer will take care of that stuff for you. Any questions about finding vertex? Next problem is the same problem, just a different question. So if you want to, actually I want to steal my picture here. Let me a sec. I guess that leads to a great philosophical question. Can you steal what is yours? All right, so same ball, same tower, same equation, different question, right? When does the ball strike the ground? So where is that on the picture? What does this refer to on the picture? All right, we got x-intercept, right? And so we do have two x-intercepts with this, right? But we can see that one is only there mathematically, not there realistically, that exists at negative time. So we can't accept that one as an appropriate answer. But mathematically, because we do, the curve does go forever, it does exist. So we're looking for this point over here. And so that's an x-intercept question. So again, just interpreting that, right? And so seeing a word like that in ground would tell us that we're looking for the x-intercepts. And what do we know about all x-intercepts? Victoria, what do we know about all x-intercepts? Or Wesley, what do we know about all x-intercepts? Marlo, what do we know about all x-intercepts? Colby, what do we know about all x-intercepts? Y is 0, yep, y equals 0. Good, Wesley, good, Maddie. So it's something 0, right? All x-intercepts are something 0. So, right, that does not mean that t is 0, because t is our x coordinate. Right? That's not what that means. It means that the whole side over here is 0. So we take our equation and say 0 equals negative 4.9 t squared plus 3577 t. Make sure your t's and your pluses don't look the same. Plus 15. So there's our equation. Right? And then solving a quadratic comes down to, we could try factoring this. Good luck with that. Okay? If we can't factor, then we're down to the quadratic formula, which is in your notes from the first day that we were doing 5.1. Pointed that out to you. It was when we were talking about how to find x, but it's negative b plus or minus the square root b squared minus 4ac all over 2a. So we are going to be finding t, not x. So I'll just write t equals, it's negative something plus or minus square root something squared minus 4 times something times something over 2 times something. So B, that's our B value, 35.77. It goes there and there. A, oops. That's our A value, the negative 4.9. Make sure you get that negative on there. And then C, that's our C value. So getting it all plugged in. I really suggest you guys do, as much of this that you can in your head. Of course, the front of that is just negative 35.77 and plus minus. That's all going to be over 2 times 4.9 is 9.8. So 9.8 is going to be negative. But trying to do all that stuff under the radical is not going to be easy, so we'll use our calculator for that. Dang it. So what I'm going to do is going to go ahead and type this into the calculator all at once and let it do all that for me. Okay? I'm not going to do the square root part, just the radicand, the part that's under the radical. Okay, so 35.77. Okay. So 35.77 squared. So then minus 4 times, then make sure you have that negative 4.9 times 15. Okay. So I get that. Okay. So I do have a longer decimal. So if I wanted to be really lazy and not write down that long decimal in the math, I can. And it's not the best idea. Okay. But when we go to do the next step, we need to make sure we use this number here without doing any rounding. Okay. It's not a really long decimal, so I'm going to go ahead and write that down. So 153734929. So now I need to do this. Now I need to figure out what the square root of that is. And so then going back to the calculator. So I want to take the square root of that. So I just hit on mine, I get the square root, and then I can just tap that down where you guys can do square root, second answer. Okay, so you don't have to retype it again. The more you interact with it, the more chances you switch a number around, drop a number, anything like that. So using your calculator's functionality to do that. Okay, so then I get 3966. All right, so I am going to abbreviate this as I write it because I don't want to write all that down. But again, as we go to do the next step of the math, we'll come back to the calculator and let it handle that for me. So I'm just going to say 397. Oops, I knew that was going to happen. I've actually been really good at this all day, and then today, right now, that's it. So now we're to the point where we need to deal with the plus minus. Oops. And so what that means is that we have t equals negative 35.77 plus 397 over negative 9.8. We also have t equals negative 35.77 minus 39.7 over negative 9.8. So without doing any math, just by looking, what type of number is this? Without doing math, just by looking, what type of number is that? Anybody out there? Yeah, so that's a positive number, right? So we have a positive number divided by a negative number, and that's going to give us a negative. And negative time, no bueno. Right? So there's no point in doing that math because there's no way the answer is right. Okay? And so then we look at this one. Right? Negative minus something else is a negative. Negative divided by negative would then give us a positive. So this is actually worth doing, okay? Giving us a positive answer. Again, as I go to do this, I want this to be in parentheses. Right? Those fractions, you gotta be careful with those. Okay? So make sure it knows to do that first. Okay. So I'm gonna go back to my calculator. So I want parentheses negative 35.77. Then I want to subtract. Now I'm going to go back and bring down that whole number. So I'm using my second answer, or I'm using my tap function here to bring that down. Notice how the calculator is opened two sets of parentheses. I need to close both. Okay. So now the numerator is held together. And then I divide by negative 9.8. Okay. And there I get my answer. And this was a time question, right? So 7 point blah, blah, blah. Okay. And I would go in around that to the nearest tenth. So 7.7 seconds. Okay. So about 7.7 seconds to hit the ground. Just a sec, guys. Anything about finding the x-intercept there you guys got questions about? Okay. All right. Next one, I changed up the situation, but it's really the kind of the same idea as far as we have a quadratic equation, something being thrown off the top of something. So this time we got a frozen chicken that's being thrown off the top of a barn. So we have a function that represents the chicken's height h, this time at t seconds after being thrown. There's our function. So again, first thing I'm gonna do is just kind of sketch this out. I'll give you guys time to write it down too. But we have a completely new question here. What time is the height of the chicken? 50 feet. So we have an h-axis and a t-axis this time. Height in feet. Time in seconds. How much of that you guys can hear? So what's happening here with this 50 feet thing, or at what times is the height of the chicken at 50 feet? So basically there's a couple different options. If 50 feet was here, we'll say that line, right? When does the chicken cross that line? So it's moving up, hits 50 feet, keeps going, comes back down, hits 50 feet again, okay? So there could be two intercepts there. Another option is that 50 feet is right here at its vertex. So if it went exactly up to 50 feet and then came back down, there'd only be one intercept there. The third thing that could happen is if 50 feet was up here, then the chick would never make it up there. So we'd have no intercepts there. So those are the kind of the options here. I don't know how, is this really disruptive for you guys as far as sound, or I don't know how bad it is on your end. Can you guys still hear me okay? Can you hear me okay, or is it just too much?
Yeah, we can hear you okay.
Okay. I'll try to hold my mic close to my mouth. So that's what we're after, though. So essentially, it's the height is 50 feet. Okay. So last time we were looking at those x-intercepts where the height was 0 feet, so we made that left side of the equation 0. Well, now I need to make that left side of the equation 50 because that's the point we're trying to see when it hits, or if it hits. So 50 equals negative 16t squared plus 88t plus 10. Okay, so setting up the equation, just like last time, we can't solve a quadratic equation until one side is 0, though. Okay, that's how that works, either by factoring or by the quadratic formula. So our first step does need to be to get the 50 over. So we set it over there, and then we need to bring it to the right side. So 0 equals negative 16t squared plus 88t, Lord, minus 40. Okay, you guys all good there? All right, so we're going to go ahead and use the quadratic formula. We could try to factor this. It might be kind of messy. I'm going to just use the quadratic formula since we're on top of that. It's still a t question, not an x question, so I'm just going to write it that way. So negative something plus or minus square root something squared minus 4 times something all over 2 times something. Angelique, what should go here? Angelique, what should go here?
I have no idea.
How dare you?
I know, right? Such a shocker for me. But no, I don't know. Negative b, so
What's our b value?
would it be 88?
All right, I got 88. Grant, what should go here? Thanks, Angelique. Grant, what's here?
That's the 10, right?
There is no 10. There's no 10 here, man.
I looked at the wrong thing.
You did.
That would be the 40.
What's that say, Grant?
That's unfortunate. That'd be the 88.
88. Jaden, what goes here?
The negative 16.
Negative 16, our a value. Cole, what goes here?
The negative 40.
Negative 40, our a or c value. And Katie, what about at the bottom? Goes here.
Negative 16.
Negative 16 or a value, all right. So making sure you get your numbers in the right spots. Again, just kind of working this down now to figure out what t is. So, of course, that outside is just negative 88. Thank you, guys. All right, plus some big number under there, all over negative 32. So we need to go figure out what all this mess is here. All right. So watch those signs there. I got 3 negatives we need to make sure we deal with. So So 88 squared minus 4 times, what was it, negative 16 times, what was it, negative 40? So make sure you have all the negatives. Maybe this one gives us a nice answer, 5184. While I'm here, I'm just going to go ahead and square root that. So square root's down to 72. Okay, so 5184 and then 72. 5184. And t equals negative 88 plus minus 72 over negative 32. So at this point, we need to break that apart, right? So we get negative 88 plus 72 over negative 32, and then negative 88 minus 72 over negative 32. What's different about this one is that both of these will have negative numerators, right? This is going to be negative and this is going to be negative. So both of these should give us positive answers when we're done, divided by that negative. So negative 88 plus 72 is negative 16. Negative 16 divided by negative 32 is positive 1/2. And then negative 88 minus 72 is negative 160. Negative 160 divided by negative 32 would be positive 5. So we see we get two answers there, 1/2 and 5. And if we go back and think about what that means, as far as our picture, okay, that'd be at a 1/2 second where it crosses there, and then that would be 5 seconds when it crosses there. In order for this situation to have happened, where it just like hits that level and then comes right back down, doesn't actually go through it, this number here would have had to have been 0. So if we'd done this math here and it all added up to be 0, then we would have run into that situation where it just comes up to and bounces and comes right back down, kind of. In order for it to do the situation where it never actually meets it, this number here would have to be negative. And then when we go to square root that negative, we get an imaginary number, right? And then so that means that there are no actual real times when it hits that level. So that's what's going on there, like how you can end up with those 3 different situations. But we see that it is actually hitting twice. So I believe on this problem, it asks you guys to write your answers just as a comma separated list. So you would just write, t equals 1/2 and comma 5. And then the seconds would probably be over there or something like that. Your box would look like this. Yeah. Any questions about how to find a particular time or a time for a particular height? Okay. All right, there's one more problem. This one's quite a bit different than the others, so I definitely write this down. It's not a very long problem, or words-wise, but it's very different than the other ones we've been doing. It's quite a number of bike helmets that a company is selling per month can be modeled by this function or expression, negative 3.15 p plus 500. And it's asking what price p of the bike helmets will maximize the company's revenue. So we see a word in there that's similar to stuff we were doing before, which is that maximize. We talked about the maximum height of it on the other one. Big issue here though is that this is not a quadratic, right? There's no square anywhere here, so that's an issue. I think it could be a problem is if you don't know what revenue is, there could be an issue. So there's stuff that's quite a bit different. They're not giving us a lot of information here. So what do we do with that, right? So there's some an assumed knowledge here, and really what it comes down to is, do you know what revenue is? Okay? And so revenue is the amount of money that you bring in, and it's not profit. Profit is the amount of money you brought in minus how much money you had to spend. That's what's profit. That's what's left over. Revenue is purely the amount of money you bring in. So if my job is to sell pencils, and I sell 10 pencils for $2 each, then my revenue is $20. Okay? If I want to figure my profit, then I got to figure out how much I bought the pencils for, and then other things like that. So, but revenue is purely the cost of the item times, or the price of an item, I guess I should say, not cost, number of those items sold. Okay. Which is good, because if we want to find the revenue based on the price, what I need to do is take the price of the item, which they've told us is just P. We want to multiply that to the number of them sold, which they've told us is this expression here. So I put that in parentheses because it's something more complex, so I'm going to make sure it stays grouped together. The other thing it helps me do is realize that I need to distribute the P into the other expression to figure out what my final answer is. So negative 3.15 P squared plus 500 P. So there's our revenue, there's our revenue function. That should have been an R instead of P. So the revenue based on the price is this. So we had to come up with the function there on our own, kind of. Any questions about how I did that? Again, if you want to sketch it out to kind of make more sense of it, P would be where our X is, so this would be our P axis, and then that would mean this would be our R axis. P stands for the price of the item. Of course, it would be in dollars. And then revenue would be our Y axis. That would also be in dollars. See that we have a inverted parabola here with the y-intercept being 0. Okay. So across there it's 0, 0. We do something like this. And we're after the maximum. So it wants the vertex of that, right? It's a vertex question, but it asks what price. Okay. Well, price is our x axis. Price is our x coordinate. So the question here is purely what's the x value of the vertex. It does not ask us what the y value is. So we could find it, but it's not asking us to. Okay. Well, how do we find x? X equals negative b over 2a. Right. So that means that p equals negative b over 2a. Our b value being 500. Our a value being negative 3.15. So as I go to type that in my calculator, make sure I put parentheses around that on the bottom. So 500 divided by 2 times 3.15. So 500 divided by, notice how I'm leaving the negatives off because I know 2 negatives is going to be positive anyways, I don't need them. Okay. So I get 79.36, blah, 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 blah. Okay. We go back to context. This is money. This is the price of a bike helmet. Okay. Money has its own set rounding levels. It's not something we come up with. Okay. So money is always 2 decimal places. So the appropriate answer here is 79.37. Okay. $79.37 would be the price that they should set it at to maximize their revenue. Okay. So 79.37. Again, that idea that if you priced them too low, more people would buy them, but then you'd be kind of selling yourself short. You wouldn't be making enough money each helmet to cover your costs. And if you price them too high, then you're outpricing yourself, and so people won't buy them enough. So again, overall you'd be making less money. So you're trying to find that sweet spot. So any of you guys that are interested in business, especially running your own business, finding out how much you're supposed to sell things for is really super important. And the math behind it, actually, some of it behind it is, thankfully, just quadratics. So really not very complex math that we had to do there, right? One distribution and then one simple formula. That's really, there's a whole lot of understanding behind that to say, okay, well, here's what I need to do with this minimal amount of information they gave me, and then what formula do I apply to it? So a lot of understanding there, not a lot of doing. Anything about that one you guys want to talk about? Assignment's pretty short. I do need to post it still. It's only like 5 or 6 questions, but it's all these word problems. It's really important that you guys, as you're working, that you're laying your work out so that if you do run into an issue, that we're able to go back and look and see what you're been up to, so that so things don't get lost all over the place. So.